Remember, those go at the end. Follow any formatting requirements that you'll see in your notebook. I have all those reference sheets for you to look at, right? Please do not copy word for word. I'm not going to go backwards a slide, right? If you're asking me that, it means that you're writing too much down. The notes are for you to process the information, to jog your memory. Do not copy them word for word. If the PowerPoint is on the website, you don't need to copy them word for word, okay? So you can always go back and look at them again. Please just take notes, use abbreviation, shorthand, things like that. This should be review information. If it's not, or you're really struggling with it, please reach out to me and we can do some more one-on-one help. In a science class, especially in chemistry, we deal with really, really big numbers and really, really small numbers, and it gets really annoying dealing with so many zeros. So we will be using scientific notation. The nice thing about that is all we have to do is move our decimal back and forth. Scientific notation is going to have one number in the front, then a decimal, then any other numbers that are there, times 10 raised to an exponent. Okay, so one number, and then the decimal, the rest of the numbers, and then times 10 raised to an exponent. The exponent is telling us how many times we need to move our decimal and which direction. Do I move it to the left or do I move it to the right? One thing you might see, especially on worksheets or sometimes on PowerPoints, you may see something called E notation. Writing times 10 to an exponent can be difficult in some programs that can't do exponents. It can take a lot of time to do it this way. So sometimes when people are typing things, they may use what's called E notation. So instead of writing times 10, you just put a capital E, and then your exponent comes afterwards. So if you ever see that, it's not something tricky, it's just an easier way to type it when you can't easily do exponents. Because this is a science class, it is not a math class. We need to be careful to understand that the numbers we use are measurements. They are not just numbers. So a measurement is going to have a quantitative piece, the actual number, but it's also going to have some kind of a scale, some kind of a unit. If you just tell me the answer is 20, I have no idea what that means. You need to actually put a unit on your answers. So we'll use a lot of scientific notation. We'll be using metric system for our units. If you don't put units on things, you get no points. I really need you to understand the difference between numbers in a math class and measurements in a science class. So the phrase that we often say in chemistry is no units, no points. So please realize that a complete answer is going to need both of these parts. Real quick, why are we going to use the metric system? Well, we need everybody using the same math language. Everybody else uses it. There's very few countries in the world that don't use the metric system. Depending on the year, I hear 2 or 3 countries that don't use it, ourselves included. So since the majority of people do, then science decided let's just all be on the same page as the metric system. It's also easier. Rather than memorizing a bunch of random conversions, what we can do is just move our decimal back and forth by factors of 10. So it may not feel easier right now because you're not familiar with it, but once you see how it works, I think you'll realize that it is a lot faster and a lot easier. Metric system works on what's called base 10. Everything is going to change by a factor of 10. Compare that to the English system, which is completely random. I don't know about you, but I do not want to have to memorize such random numbers like this. If you look at the metric system, you can see that they're just increasing or decreasing by 10 each time. And that's going to make our life much easier. So we do not want to use the English system unless we have to for some reason. When we convert, there are lots and lots of prefixes that we can use to tell people which way to move the decimal and what size our number is. The ones that you need to memorize are these on the screen. You need to memorize from kilo to milli. There are bigger and smaller prefixes, but those are ones I would tell you or allow you to look up on the internet. These are the ones we really need to memorize. We have kilo, hecto, deca, what I call base unit, and then deci, centi, and milli. And what we'll do is if I want to go from kilo to centi, I'm just going to count how many times I move my decimal. And I'm going to move it in the direction that I see on this little staircase, either to the right or to the left, depending on which way we're converting. The way I remember the prefixes, when I was in high school, I was taught to use this mnemonic. King Henry died by drinking chocolate milk. There's lots of mnemonics out there. I've heard all sorts of crazy ones. I don't care which one you use. I use King Henry because that's the one I was taught when I was in high school. So if I ever tell you something like you can use King Henry, what that means is you can just move your decimal back and forth. I'm referencing this mnemonic of the prefixes. Base unit is going to be the unit that does not have a prefix attached. So we're used to things like centimeters. Well, centi is the prefix and meter is the unit that we're talking about. So in here in the middle, this step, this base unit are going to be the ones that do not have prefixes. We have meter, liter, gram, seconds, Kelvin, moles. These are the ones that we will be using wherever it says base unit. We're going to do a couple of practice problems. Remember, the practice problems are required. They are part of the lesson. Please take good notes and do them in your notebook. Let's convert from milligrams to grams. So we first have to stop and ask ourselves, well, which direction am I going? If I have my King Henry died by drinking chocolate milk going on here, what I need to do is figure out where am I starting and where am I stopping. I'm starting at milli, and grams does not have a prefix, so it's a base unit. So I'm going to end here at the base unit. Next, I need to count how many steps it takes to get there. I'm trying to figure out how many times am I changing by a factor of 10. So for this case, it's 1, 2, 3 times. Now I'm going to take my starting number and I'm going to move my decimal 3 times in the same direction. 1, 2, 3. So 27.5 grams is exactly the same as 27,500 milligrams. And I don't know about you, but I think it's easier to say 27.5. So if this were me, I would probably put my number in this format using this unit. If I were doing something else, maybe my scale measures milligrams, then I could convert it and leave it like this up here. The nice thing about conversions is we can change what the number looks like to make our life easier. I don't want to deal with big numbers and I don't want to deal with small numbers. So I can just change the size of the unit, and it doesn't change the measurement. It's still the same quantity. The number will just look different based on which unit size I'm using. So let's try another one. The capital D stands for deca. A lowercase d would stand for deci. So this one we're going decaliters to milliliters. So are we going up or down the ladder? Well, here's deca, here's milli. So I'm going to go that direction this time, to the right. It's going to take 1, 2, 3, 4 times of moving my decimal until it's converted. So here's my starting number. I'm going to move it 1, 2, 3, 4 times. And now I have my final answer. So 0.15 decaliters is the same amount as 1,500 milliliters. Now sometimes people will stop me and say, wait a second, you didn't have zeros at the end up here, but you had zeros down here. Well, I need them as placeholders, right? So I can add them there because I need to make sure that I have these places saved. You do need to be a little bit careful about the difference between what we call a base unit when we're doing our conversions and something called an SI base unit. So an SI base unit is a whole other system that is agreed upon in science, and for the most part they're the same as our base units, but every once in a while there is one that's a little different. So for example, kilogram is an SI base unit, whereas a normal base unit would just be grams. So I wish we had all picked a different term for these things. Unfortunately, we didn't, so it's a little confusing. So when I say base unit, I mean the one that has no prefix. That's what I'm going to mean this year. Derived units are what we get when we combine multiple units together to make something a little more complicated. So for example, if we're driving in the car, we tell people that we're going to travel in miles per hour. I'm taking a distance and I'm taking a time and I'm combining it into a new unit that is going to tell me something new, in this case, speed. You might see something called centimeters cubed. Well, centimeter is a length, but if I combine 3 of them together, centimeter times centimeter times centimeter, then it's going to give me volume. So centimeters cubed is a derived unit. If you take physics, we see this a lot. So in physics, they use a lot of derived units because they're doing things that are combining lots of different pieces together, and they get these brand new units. You can see here's some SI base units, and then here's all the crazy things that they can combine and make new units out of. So I'm never going to ask you to learn all of these. I do think it's very interesting to see them and see that it can get very complicated very quickly when we start combining these things together. The nice thing about chemistry is we don't have a lot of derived units. We sometimes do, but most of our units are pretty standard. All right, that's it for this lesson. I hope that was helpful. Bye, everybody.